guys. I just thought that I would start, just showing my face at the beginning of these videos. Just checking in with you before we start our notes. I hope you had a good day yesterday, good day today, and you're ready for some math. I do want you to know, just because I think that, just adding a little flair, personal business to our emails or our videos, I am currently reading Alexander Hamilton. It's the book that inspired Lin-Manuel Miranda to write the musical Hamilton. It's actually really interesting. I recommend it. I mean, who would have thought that this non-fiction, fictional, historical fiction, because, it's got a little bit of embellishment in it, but I'm learning a lot right now. So, that's what I've been doing. Missing you. And now we're going to take some notes. We are today, so we've been factoring, right? We are going to continue factoring. We are working with basic, really simple trinomials today. And we're unfoiling. So remember last unit we spent all that time foiling when we had a binomial and a binomial. Oh, that's really close. A binomial, and we first outside, inside, last. We're going to undo that today. It's really hard to tell where the camera is. The camera's over here. So let's get started. Let me turn this around. There's no cat in the bed yet. They're ignoring me this morning so far. All right, so 2 pages today. Let me get my pens. We are going to factor. Uh-oh. Maddie's probably yelling at me. That's the wrong color of purple. Factor x squared plus bx plus c. So this is a trinomial, right? And if you'll notice, it is just starting with the variable squared. There's no leading coefficient. So that's what's special about it. And today we're going to unfoil it, right? So we're going to factor a trinomial. And we're going to do some practice. All right, page 101. Factor x squared plus bx plus c, which is unfoil. Oh, there we go. Downfall of not seeing you guys every day. 1, I miss you. 2, no one can tell me when my screen doesn't show what I'm writing on. All right, so this skill that we're working on only works for a trinomial. So it has to be 3 terms. And the leading coefficient is 1. If you have a leading coefficient that's not 1, we need to try to make it 1, meaning we're going to look for a GCF, or we can't do it yet. We'll learn how to do it, but right now our leading coefficient must be 1. And if we can't make it 1, meaning we can't factor out a greatest common factor that results in the leading coefficient being 1, we're not going to be able to do it today. So you have to ask yourself, every time you look at one of these problems, you have to ask yourself this question. You have to say, what factors of C, so the constant at the end, have a sum of B? Does this sound familiar? We've been doing this in our bell work all year, preparing for this moment. When I say factors of 20 that have a sum of 9 on your bell work, you would say 4 and 5, right? So we are looking for factors of that third term, the last term, the term without a variable, the plus or minus number, that have a sum of B, which is that middle term. So we're going to walk through these problems. If I have the trinomial x squared plus 10x plus 24, I want factors of 24 that have a sum of 10. So factors of 24, what times what makes 24, but has a sum of 10. And if you're not good at these, you're not confident with it, we can go into our factor squares and I can look at 24. I have 2 and 10. Well, I could make, or 2 and 12, sorry. I could make 10 out of that, but one of them would have to be negative, and that would not give me positive 24. So 6 and 4, does 6 and 4 work? 6 times 4 is 24, 6 plus 4 is 10. So my answer, I'm unfoiling it. Remember, I'm taking this trinomial and I'm breaking it into two binomials. So my answer is just gonna be x plus 4 and x plus 6. Or you could flip these two binomials around, right? Commutative property of multiplication says that the order of multiplying does not matter. But that's it. Because if I distribute, right, if I foiled this, x times x is x squared. X times 6 is 6x. X times 4 is 4x. 6x and 4x make 10x. And 4 times 6 makes 24. So if you have a simple trinomial, meaning the only it is a leading coefficient of 1, then we look for factors of c that have a sum of b. So let's try b squared plus 19b plus 60. So I'm looking for factors of 60 that have a sum of 19. So if you don't know factors of 60 that have a sum of 19, we're going to go back to our factor squares. I'm going to go to 60. There's a lot in here. 2 and 30, no. 3 and 20, no. What am I looking for? 19. 4 and 15, 4 and 15 make 19. So b plus 4 and b plus 15. And I factored it. So again, you have to have a leading coefficient that's 1. So sometimes the leading coefficient is negative, right? We've encountered that before. You need to factor it out. And sometimes there might be a GCF. So let's do 2 of those problems. It is, let's see, negative y squared, so negative leading coefficient. I know that's going to have to change. Plus 2y plus 15. My leading coefficient is negative, so I need to factor that out. So I'm going to take it and I'm going to make it negative 1 and leave behind y squared. It changes to negative 2y and changes to minus 15. So now I have a negative value, right? I'm looking for factors of negative 15 that have a sum of negative 2. So the only way to make negative 15 is 1 positive and 1 negative, right? I'm looking for factors of a negative value, and the only way to get a negative value is 1 positive, 1 negative. So if you don't know your factors of 15, you can go right here. Only way to get it is 3 and 5. So which one? I have to have negative 15 to get multiplied, but I need negative 2 when I add them, meaning that my 5 is the negative value. So y minus 5 and y plus 3. Negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. Do not forget, I factored out a negative 1 at the beginning. My leading coefficient was a negative value. We are just going to practice, practice, practice. So don't panic. It gets easy once you start just seeing the patterns. So let's now go with a greatest common factor. So 4x squared plus 8x minus 252. Yowzers, right? First off, leading coefficient, it has to be 1, and it's not 1. So I'm going to look, can 8 be divided by 4? Yes, because if I get rid of that 4, I have a leading coefficient of 1, right? If I factor out that 4. So let's factor out the 4. I don't know where my calculator went. Factor out the 4. X squared plus 8 divided by 4 is 2x. 252 divided by 4, 63, minus, right, because it's a negative, 63. And then remember, I'm going to have to take that down in my answer. So I'm looking for factors of negative 63 that have a sum of positive 2. So what times what makes negative 63? But when you add those values together, you get a positive 2. So if you don't know 63, see how helpful these are? How do I get 2? I want positive 2. How do I get positive 2 from these factors, right? I can do 3 and 21 or 7 and 9. How do I get positive 2? 9 minus 7. So the negative is belonging to the 7. So x minus 7 and x plus 9. Multiplied together make negative 63, but added together make positive 2. Then I had that leading coefficient of 4 at the beginning. It's beautiful, right? So again, you have to ask yourself, factors of C that have a sum of B. We're going to keep practicing, so don't panic yet. Let me move this a little bit and turn this. Sorry if this is making you seasick. Okay, so let's keep practicing. All right, we're going to include one more little piece in here, and it's going to be a difference of squares, and I'm going to show you the long way around it, and then I'm going to talk through a little bit of a shortcut, but you don't have to use a shortcut if you don't want to. So, if you're given a binomial like this, x squared minus 64, that's really a trinomial, right? Because again, this is my x squared and this is my c value. And in the middle, I'm missing the bx. Right? I've got my x squared, I've got my constant, I'm missing that bx, but I can rewrite that. I can rewrite this problem as x squared plus 0x, because it's not there, it's missing, minus 64. So if I rewrite this with that 0x inside of it, and it has to be a difference of, it has to be a subtraction problem for this to work, and it has to be x squared with this constant. But if I rewrite it, I can do factors of negative 64 that have a sum of 0. And so what times what makes negative 64, but when you add them together, you get 0. So if I go back and look at 64, to get 0, right, I know that I have to have a negative value in multiplying, so one positive and one negative. And to get 0, which ones cancel out? 8 and 8. So it is x minus 8 and x plus 8, because negative 8 times positive 8 is negative 64, but negative 8 plus 8 creates 0. Again, this only works if you have a negative right? You have to have that, it has to be a minus. And it also has to be a perfect square. If it's a negative, if it says minus, and it's a perfect square, then you can put that 0 in there and factor it. For example, these ones won't work, like y squared minus 10. It's a minus, but this is not a perfect square. So it doesn't factor. It's done. No factors. If I had m squared plus 81, this is a perfect square, but it's positive. And since it's positive, right, the factors of 81 are 9 and 9, but there's no way to make 0 with positive 9 and positive 9. You could do negative 9 times negative 9 to get positive 81, but you still can't get 0. So this is no factors. But if you have a negative perfect square, right, minus 64, it's a negative and it's a perfect square, I can create 0, which is my middle term that's missing, by doing negative 8 times positive 8. Negative 8 times positive 8 is negative 64, but negative 8 plus 8 is 0. Let's just do some practice. Let's just get some practice done, all right? Let's do a GCF one with this. Let's do x to the third minus 9x. Well, it's a binomial, but do they share anything? So the first thing we need to always ask ourselves, just whenever we're factoring, is there a GCF? If there's a GCF, get rid of that GCF, get that GCF out of there, so we can x squared minus 9. So we can continue to work. And then this is gonna have to come down, right? Because I have a GCF. All right, then I'm gonna look and I'm gonna say, okay, this is a binomial. The only thing I can do with a binomial, we just learned up here, can I rewrite it as x squared plus 0x minus 9? I can, because this is a minus and a perfect square. So I'm looking for factors of negative 9 that have a sum of 0. What times what makes negative 9, but when you add it together, you get 0? Anybody? Have you thought of it? X minus 3 and x plus 3. And remember, I had a GCF at the beginning, which was the variable x. Beautiful. Let's keep going. Let's do this. Negative 10x squared minus 50x plus 15. All right, so first things first. There's a negative coefficient, correct? So I'm going to take out that negative. Can they also be divided by anything else? Can 10, negative 10, negative 50, and 15, do they have a greatest common factor? Negative 10, negative 50, they have 10 in common, but 15 doesn't have 10 in common. Oh, they can be divided by 5. But also, remember, I've got that negative, so let's take out a negative 5 from everything. Negative 10 divided by negative 5 is positive 2x squared. Negative 50x divided by negative 5 is positive 10x. And 15 divided by negative 5 is negative 3. We have to stop. We cannot today continue to factor this because I do not have a leading coefficient that's 1. I can't continue to factor. I need to stop today. Later on, we'll learn what to do with these, but today I'm stopping. Let's do another one. over here. Let's do 2x squared plus 50x plus 48. So I have a coefficient, leading coefficient, that is not 1, and I need to try to get rid of that if I can. So is there a greatest common factor with 2, 50, and 48? Yes, they're all even, so they can all be divided by 2. So let's take out a 2. I'm going to draw that down. I have x squared plus 25x plus 24. This is the one that stumps us all the time. Are there factors of 24 that have a sum of 25? Maybe there aren't. Maybe we're done. Maybe there's no way to factor it anymore. However, anybody think of any factors? What times what makes 24 but has a sum of 25? 1 and 24. 1 times 24 is 24, but 1 plus 24 is 25. I had that greatest common factor that I took out that I'm going to put at the front. It's beautiful. All right, so we are factoring. Remember, factors of C that have a sum of B. That's what we're looking for. Factors of C that have a sum of B. If you have a binomial and it's a subtraction, right, with a perfect square, you can add that 0 in and factor it. If it's not a perfect square, you can't factor it. If it's a positive, a plus, a perfect square, you can't factor it. You are looking for factors of C that have a sum of B today. And when you find, if you find factors of C that have a sum of B, you just write them down. The leading coefficient must be 1. If you have questions, send me an email. We can work through some problems together. Bye.